Hello, welcome back. In this section, we'll talk about improper integral. The definite integral we have accounted so far involve finite value, right? Finite value function and finite interval of integration. In this section, you will see that a defined integral can sometimes be evaluated when these conditions are not met. So we will have cases like the interval of integration is infinite, or the integrand is unbounded on the interval of integration. So, like definition, proper integral over infinite interval. So if f is continuous on the interval close from a to infinity, then the integral of f of x dx from a to infinity is equal to the limit of the integral from a to b f of x dx as b goes to infinity. This is, you can see, this is the interval from a to b, right? So as b is going to what? Positive infinity. If you are looking for this area, this is the formula you have to use. You can use the limit. And if f is continuous on the interval from negative infinity to b, then the integral of f of x dx from negative infinity to b is equal to the limit of the integral from a to b f of x dx as a goes to negative infinity. You can see that's the case. A is going to negative infinity. And 3, if f is continuous on the open interval negative infinity to positive infinity, then the integral from negative infinity to positive infinity f of x dx is equal to the limit of the integral from a to c f of x dx as a goes to negative infinity plus the integral from c to b f of x dx as b goes to infinity. And this is the case. You can see a is going to negative infinity, b is going to positive infinity. You can have c. So if you can find this area plus this area, where c is any any real number, it can be shown that the choice of c does not affect the value or convergence of the original integral. So c can be anywhere on between a and b, so it will not affect the value or the convergence. If the limit in case 1, 2, or 3 exists, then the improper integral converge. Otherwise, they diverge. So pause the video, read, try to understand before we attack the first example. So the first example is evaluate each integral. Evaluate the integral from 0 to infinity ex dx. So I'm just going to follow my definition. So to find the integral from 0 to infinity e of x dx, it will just be equal to the limit b approaches to infinity, 0 to b. Sorry, this is e to the power of negative x, okay? That's what I mean, e to the power of negative x. You can do with e to the power of x as well. So which will be the limit as b goes to infinity. The antiderivative of e to the power of negative x is negative e to the power of negative x from 0 to b. Which will be the limit as b goes to infinity 1, because if I substitute b first, sorry, if I substitute b, it will give me negative e to the power of negative b minus, if I substitute 0, it will give me 1. If this negative, negative 1, so I'll have plus 1, right? And then now we need to find this limit. That's what will be my final answer, which you can see, this is same thing as what the limit of 1 minus 1 divided by e to the power of b as b goes to infinity. So this will be 1 divided by infinity, which is 0, and 1 minus 0 is 1. So this limit is equal to 1. So that will be my final answer. So that means the integral is equal to what? 1. Okay, and of course, if I did with e to the power of x, you will see that will give me infinity, so which means it will be diverged. If I kept with positive e to the power of positive x, it will be, the limit will be infinity, so that means this integral diverge. Okay, so b dx over 1, the integral from negative infinity to positive infinity, d of x over 1 plus x squared. So again, to find this integral, I will write the integral from negative infinity to positive infinity dx over 1 plus x squared is equal to the limit using the definition, right? You said the integral of a to c d of x over 1 plus x squared plus the limit p goes to infinity c to b d of x over 1 plus x squared, which will be, the antiderivative of 1 divided by 1 plus x squared is what? Tangent inverse, right? Tangent inverse of x. So we will choose our c to be 0 in this case, okay? I'm going to choose c because, since 0 is easy to evaluate for tangent inverse, as I said since the beginning, choosing different c will not change the value, right? I can go back after this one to explain that part to you again. But you can take c to be anything. But if you have a function, always choose the constant that is easier to substitute. Because if I substitute 0, That's much more easy for me. So a to 0 plus the limit tangent inverse of x 0 to b, which will give us tangent inverse of 0 is what? That is 0. So we'll have 0 minus tangent inverse of a, as a is going to negative infinity, plus the limit tangent inverse of b minus 0 as b is going to infinity. So evaluate the limit. You can see as tangent inverse of negative infinity is pi over 2 plus pi over 2. Tangent inverse of infinity also is pi over 2. So this limit will be pi over 2 plus pi over 2 is pi. What I mean is about choosing your c. You can choose your c to be anything. C can be equal to 0, can be equal to 1. Why? Because even if you choose c to be 1, you know, tangent inverse of 1 is what? Tangent inverse of 1 is pi over 4, right? So you will still have a pi over 4 minus pi over 4, which will be canceled out. Because you will have a pi over 4 right here. You will have a minus pi over 4 right here. So that will still cancel out. Okay? Okay, so let's move on to the next problem. We have let R be the region bounded by the graph of y is equal to x to the power of negative 1. And the x-axis for x greater than or equal to 1. Right? We are asked what is the volume of the solid generated when R is revolved about the x-axis. So, you know, we have done these problems before, but if I have it to solve, you know, I don't need to sketch, but again, I'm going to give you a brief sketch of what we have going on. You know, if you look on this is x to the power of negative 1 is same thing as y is equal to 1 divided by x. So the graph is something like this, right? So about the x-axis, so this will be r. So if it's rotated about the x-axis, because it's just like we will have something like this right here as well. Don't mind my graph, right? So that's kind of the graph because this is y is equal to 1 divided by x. That's the graph. So this will become my the volume that we are looking for. Okay. So A, you know, the region R and the corresponding solid revolution are this one. So again, it said x has to be greater than or equal to 1. So if this is 1, and then we will choose a b. B is going to infinity, right? So that's something we have to do. So we use, in this case, we use the disk method, okay? And you know why. To find the volume, the disk method over which interval? Over the interval 1 to b. And we know b is going to infinity. Okay? So in this case, my volume will be equal to, from 1 to infinity, pi times f of x squared dx, this is the disk formula for the volume. And what is our f of x? 1 divided by x. So we'll have 1 to infinity. Let me copy, I'm gonna graph this and paste it here, okay? So you can see this is the graph, okay? Y is equal to 1 divided by x, and this is the region. So let's continue with our volume. So we know this will be 1 to infinity. I mean, sorry, 1 to b, because we said let's this be equal to b. So let me substitute my function first. So 1 to infinity pi times 1 divided by x squared dx. So we know, using the definition of improper integral, pi is a constant, so we can take pi out, right? Pi can be even in front of and behind a limit because it's a constant. 1 to b 1 divided by x squared dx, which will give me pi, the limit, the antiderivative of 1 divided by x squared is, the antiderivative of 1 divided by x squared um, is a negative 1 divided by x. From 1 to b. Right, so if I substitute my b, I will have negative 1 divided by b, and if I substitute 1, I will have positive 1, right? So which would be pi times the limit of 1 minus 1 divided by b, which is equal to what? Pi. So the proper integral exists because it gave me a finite solution, and the volume of the pi cube, the solid has a volume of pi cube. Okay. And then B, what is the surface area of the solid generated when R is revolved about the x-axis? So same thing. Let's solve this one. B, again, the surface area generated formula using on chapter 6 is 1 to B, right? 2 pi f of x. Before I write this one, let me write the surface area because that's what we are looking for. Yeah. The surface area on the interval 1 to B is what? 1 to B, 2 pi f of x square root of 1 plus f prime of x square dx, right? So which means for our case, the area of the surface generated generated on the interval 1 to infinity is found by letting b goes to infinity. So I will write my surface area. My surface area is equal to, 2 pi is a constant. So I will take 2 pi out. The limit of b goes to infinity, 1 to b, the integral from 1 to b f of x times square root of 1 plus f prime of x squared dx. So we know how to find f prime of x, right? So this one will give me 2 pi, the limit as b approaches to infinity, 1 to b, 1 over x square root of 1 plus 1 divided by x square dx. we have to simplify everything again. You know, if I take me, this derivative is negative 1x squared, right? So if I square, it would give me x to the power of 4. I can factor x to the power of 4 outside. So what I mean is, this will give me 1 divided by x to the power of 4. If I factor x to the power of 4, what I will have is what? X to the power of 1 plus x to the power of 4, or x to the power of 4 plus 1 is same thing. X to the power of 4 plus 1 dx. We can take 1 divided by x to the power of 4 outside the integral. So it will become 1 divided by x squared. Right? So that will become 1 divided by x squared times the limit. One to b, so this one will be 1 divided by x cubed. Right? So again, to find this integral, you can use substitution. But since we are looking for the integral, I can see this one diverges. So you can use comparison test to check, because you know that we can see on the interval of integration, we know. Okay, let me write this so you can take it. On the interval of integration, we know x is what? Positive, right? X is greater than or equal to 1. Or if you look at the term under the square root, what do we have? We know square root of 1 plus x to the power of 4 is greater than square root of x to the power of 4. That's true, right? And what is square root of x to the power of 4? That is x squared. We know this is x squared. So the integrand, I'm just trying to prove that the integrand, this integral diverge, okay? So what do we have there as well? We have 1 divided by x cubed times square root of 1 plus x to the power of 4 will also be greater than what? 1 divided by x cubed times x squared. That makes sense to everyone, right? Because if the first statement is true, then this statement is true as well. And x squared divided by x cubed is what? 1 divided by x. So, look, therefore, we know for all b with, of course, 1 is less than b, and b is less than what? Infinity. We know the surface area is equal to what? 2 pi integral from 1 to b, 1 over x cubed square root of 1 plus x to the power of 4 dx. This surface area also will be what? Greater than 2 pi integral of 1, integral from 1 to b. The limit of integration is from 1 to b, 1 divided by x dx, right? Based on what we said right here. And because you can see, if I find this integral, because two pi limit of b approaches to infinity from 1 to b, 1 over x dx. This limit will give me infinity. Because what is the antiderivative of 1 divided by x? That's ln x, right? Because this one will give me basically 2 pi, the limit b goes from infinity, ln of absolute value of x from 1 to b. So we know this one will give me infinity, because if it would give me ln of b, ln of infinity is infinity, right? So this is infinity. So that is why, so 2 pi, again, 2 pi limit b goes to infinity of 1 to b, 1 over x dx is equal to infinity. This implies what? Because, again, look, this is greater than this one, right? Let me use, this is greater than this integral. So once we find the integral, the smaller integral is infinity. So of course, the one that is greater than also will be what? Infinity, right? Implies that 2 pi limit of b approaches to infinity, 1 to b, 1 divided by x cubed will also be equal to infinity. Therefore, we will discuss this one at the end, okay? This is called comparison test. Therefore, the integral diverges. And the surface area and the surface area of the solid is infinite. Okay. So the last question is, what is the volume of the solid generated when R is revolved about the y-axis? So again, you know, when it's revolved about the y-axis C. So or the y-axis. Okay, let me try to sketch that so you can have an idea about it too. So, still it will be something like this. One is revolve about the y-axis. But in this case, we will use the shell method. So using the shell method, on the interval 1 to b, and letting b goes to infinity. The volume is given by the integral from 1 to infinity 2 pi x times f of x dx. That's the shell method, right? And then what is our f of x? Our f of x is 1 divided by x. 2 pi is a constant, so it will be 2 pi, the integral from 1 to infinity, x times 1 divided by x dx. So which is 2 pi, 1 to infinity, 1 dx, right? So now letting our b goes to infinity, we will have 2 pi, the limit, as b approaches to infinity, 1 to b, 1 dx, which would be 2 pi, the limit of b approaches to infinity, b minus 1, which is equal to what? Infinity. So revolving, so this means what? Revolving the region R about the y-axis, the volume of the resulting solid is what? Infinite. Okay, so now let's talk about next section. So I hope you understand this one. Next step, next thing to learn, definition of improper integral with an unbounded integral. So this is what unbounded integral. So you can see, suppose f is continuous on the open interval at a and close at b with the limit of f of x as x approaches to a is equal to plus or minus infinity. Then the integral from a to b f of x dx will be equal to the integral, will be equal to the limit of the integral c to b f of x dx as c approaches to a plus. And suppose f is continuous on the closed interval at a and open at b with the limit of f of x as x approaches to b from the left side is equal to plus or minus infinity. Then the integral from a to b f of x dx is equal to the limit as c approaches b from the left, the integral from a to c f of x dx. Okay. And then 3, suppose f is continuous on the closed interval a to b, expect at the interior point p, where f is unbounded, then to find the integral of f of x dx from a to b, it should be equal to the limit of c approaches p from the left, the integral from a to c f of x dx plus the limit as d approaches p from the right, the integral from a to b f of x dx. So you see we have graph from both cases. In this case, can you see c is approaching a from which side of a? The right side. C is approaching b from the left side. And in this case, can you see c is coming from p, the left side, and d is on the right side. If the limit in case 1, 2, 3 exists, then the improper integral converges. Yeah, otherwise, they diverge. So let's do this first example. We are asked to find the area of the region R between the graph of f of x is equal to 1 1 divided by square root of 9 minus x squared and the x-axis on the interval -3, 3 if it exists. So again, my solution in this one will be what? We know the integrand, this integrand is what? It's even, right? And of course, and has a vertical asymptote at x is what? Plus or minus 3. So by symmetry of the area, because again, by symmetry, let me first write why I'm using symmetry. Let me write the integrand. The integrand is even. So by symmetry and has a vertical asymptote. And has vertical asymptotes at what? X is equal to plus or minus 3. So by symmetry, we know the integral from -3 to 3, 1 divided by square root of 9 minus x squared dx will be equal to 2 times the integral from 0 to 3, 1 over square root of 9 minus x squared dx. Assume this integral, assume this improper integral exists. Because the integrand is unbounded at x is equal to 3, we replace the upper limit 3 by c, okay? So now, I'm going to write my area, which is 2 integral from 0 to 3, 1 divided by 9 minus x squared. Because it's unbounded at 3, I'm going to use my limit as c approaches. Well, where do you think c will be approaching? 3 from the left, right? Integral 0 to c dx over square root of 9 minus x squared, which will be 2 limit as c approaches 3 from the left. You know, the entire derivative of this one is sinus inverse of a is 3. So x divided by 3. Let's go from 0 to c. So which is 2 limit c approaches 3 from the left, sinus inverse of c divided by 3 minus sinus inverse of 0. So we know sinus inverse of 0 is 0. And then if I find this limit, 3 divided by 3 is 1. Sinus inverse of 3, sinus inverse of 1 is pi over 2. And then pi over 2 times pi is pi. So this one will be 2 times pi over 2 minus 0, which is pi, right? So that means the surface area is what? Pi. Next, we have to evaluate the integral dx over x minus 2 to the power of 1/3 from 1 to 10. So again, we can see again this integrand is unbounded where? You can tell me this integrand is unbounded at x is equal to what? 2, because if x is 2, we will be dividing by 0, which is not possible, which is an interior point between 1 and 10, right? Is an interior point. So we split the interval, we split the interval into 2 sub-interval and evaluate and proper integral on each. So I would say my integral from 1 to 10 dx over x minus 2 to the power of 1/3 will be equal to the limit c approaches 2 from the left, 1 to c dx over square root of x, I mean, y, I like square roots, divided by x minus 2 to the power of 1/3 plus the limit of d approaches to 2 from the right, d to 10 dx over x minus 2 to the power of 1/3. So this one will be equal to what? The limit c approaches 2 from the left. The entire derivative of this is 3 divided by 2 x minus 2 to the power of 2/3 1 to c plus the limit d approaches 2 from the right, 3 divided by 2 x minus 2 to the power of 2 divided by 3 from d to 10. So again, you need to know, just use substitution. Just use substitution to find this integral, okay? Use substitution. You can see, I'm going to put it right here. Let u be equal to x minus 2. That's what you need to use. And then you will get your integration, do your things, okay? So this will be equal to what? 3 divided by 2. And let me bring this a little bit to the left. So this will be equal to 3 divided by 2. Since that's a constant, I'm going to factor that. It's the limit of c approaches 2 from the left. Let me use this as a bracket. Parentheses, we'll have c minus 2 to the power of 2/3, right? Minus, if you substitute 1 again, so 1 minus 2 to the power of 2/3 plus, again we factor 3 divided by 2, the limit of the approach is 2 from the right. Hold on, let me, that will come at the end. We will substitute first 10. So we'll have 10 minus 2 to the power of 2/3 minus the limit as the approach is 2 from the right, d minus 2 to the power of 2/3. Okay, So now we have to combine like terms and try to figure out what we will have. We will have 3 divided by 2. Okay, if I substitute 2 for C, I will have 0. 0 to the power of 2 thirds is 0. So we'll have 0. 1 minus 2 is negative 1. And 0. So we'll have 0 minus negative 1 to the power of 2 thirds, right? Plus, I already factored 3 divided by 2, right? 10 minus 2 is 8, so 8 to the power of 2 thirds, right? Minus, if I substitute 2, that would be 0 as well. Use your calculator and combine like terms, you will see this will give you 9 divided by 2. That's it. Okay, let's do the last part. Theorem, we have comparison tests for improper integrals. So this is used sometimes, to check if the integral diverge or converge. Okay, suppose the function f and g are continuous on the interval a to b with f of x greater than or equal to g of x, which is greater than or equal to 0 for x greater than or equal to a. If the integral from a to infinity f of x dx converge, then the integral of a to infinity g of x dx also converge. So look, because f of x is greater than g of x, so if f converges, that means g also converge. But if the integral of a from a to infinity g of x dx diverge, then f of x also diverge because f of x is greater than g of x. So the integral also diverge. So you can see this is the graph. So you can see f of x is the blue one, which is greater than g of x, which is also positive. So we are asked use the comparison test to determine whether the following integral converge. If they don't converge, that means what? Diverge, right? Okay, let's do this quick. So we are going to use the comparison test. So you can see if I'm using comparison test to check if this converge or diverge, first thing we all know x is less than or equal to x squared, right? That is true, right? And we can see from there, we know e to the power of x also will be less than or equal to e to the power of x squared, right? On the interval 1 to infinity, right? Which imply, since if this is true, then e to the power of negative x will be what? Greater than or equal to e to the power of negative x squared on 1 to infinity. You can graph both and check, right? Therefore, we are going to let f of x be equal to e to the power of negative x and g of x be equal to e to the power of negative x squared. So we can see f of x is greater than or equal to g of x. And of course, we know they are both positive, right? Which is also greater than or equal to 0. So if I can check if the integral of f of x diverge, so that means this one diverge, right? If it's if I can prove f of x converge, then g of x also converge. But because that's what we have to find the integral of e to the power of negative x squared. So the integral from 1 to infinity f of x dx is what? The integral from 1 to infinity e to the power of negative x dx, right? Which by the improper definition we have to make it as the limit as a approaches to infinity, the integral from 1 to infinity, 1 to a e to the power of negative x dx, right? So that will give me the limit as a approaches to infinity. The entire derivative will be negative e to the power of negative x 1 to a, which would be the limit as a approaches to infinity, negative e. We have already solved a problem like this, plus e to the power of negative 1, right? And then this will give me what? This integral converge because it will give me 1 divided by e, right? Because if I substitute infinity, e to the power of negative infinity will be 0. 0 plus e to the power of negative 1 is 1 divided by e. So converge, right? So since f of x converge, so I can say, therefore, let me move first, right? Therefore, by the comparison test, by the comparison test, the integral from 1 to infinity e to the power of negative x squared dx converge as well, right? That's how this is done. So same thing we will do right here, okay? So b, we have the integral from 1 to infinity, 1 divided by cube root of x squared minus 0.5 squared. So again, we will take, one challenge, choosing the appropriate improper integral for comparison. So that's the challenge that you can have. So we can see this is cube root of x squared. So I know 1 divided by cube root of x squared is approximately, minus 0.5. This is approximately equal to what? 1 divided by cube root of x squared, which is same thing as what? 1 divided by x to the power of 2/3. So which suggests that we compare. So this suggests that we compare what? So in this case, we will be comparing our integral 1 to infinity 1 divided by q root of x squared minus 0.5 dx to the integral from 1 to infinity 1 divided by x to the power of 2/3 dx. Again, I will give you this rule at the end. Okay. So you can see we just need to show that this one diverge or converge, right? But if you look, the integral from 1 to infinity 1 divided by x to the power of 2/3 dx, it's same thing as the limit as a approaches to infinity, the integral 1 to a 1 divided by x to the power of 2/3 dx, right? So I can use my substitution again. So this will be the limit as a approaches to infinity 1/3 x to the power of 1/3 from 1 to a, right? And if we look, this will be the limit as a approaches to infinity. We can take 1/3 out. A to the power of 1/3 minus 1. Infinity, a goes to infinity, so this one will give me infinity, which means this diverge, right? Or we know, since we're here, so we know which one is greater than, right? So we know this is less than or equal to this one because we have minus 0.5. So this has to, sorry. This is greater than this because we have minus 0.5, right? It's on the denominator. So our integral, so if I make this one f of x, this would be gx, right? So you can see if we know 1 divided by cube root of x squared minus 0.5 is greater than or equal to 1 divided by x to the power of 2/3, right? So if this is f of x and this is g of x, so we just proved that gx diverge. So since the integral from 1 to infinity of 1 divided by x to the power of 2 thirds dx is equal to infinity, which means diverge. Therefore, right, by comparison test, the integral from 1 to infinity dx over cube root of x squared minus 0.5 diverge. That's it for this section. See you in the next one.